Solving remove all from the linked list chapter. They have their own linked list implementation here, so you guys can take a look at that. Yeah, so anyways, write a method remove all that removes all occurrences of a particular value. For example, if a variable list contains the following values: 394, 238, 17, 43, 18, the call to list of 3 would remove all occurrences of 3 from the list. If the list is empty or the value doesn't appear in the list at all, the list should not be changed by your method. You must preserve the original order of the elements of the list. Assume you're adding it to this class. Alright, so basically the idea is that like when we see, so we're gonna check one ahead, right? We're gonna be at this, when we're at this node, we're actually going to be checking what's in this node. When we're at this node, we'll actually be checking what's in this node. So that's what I mean by one ahead. So we'll be one ahead while we're checking whether or not the next value equals to our target. And if it does, we're going to rearrange the links. And if we're checking one ahead, that means potentially we could miss the head value, and the head value could potentially be equal to the target value, so we need to remove that. So at the end of our loop, so when we loop through all of these values, right, and we check if any of them equal the target, then at the end, when we break out of the loop, we need to make sure to check the head, because since we're doing a one ahead implementation, well, since I'm doing a one ahead implementation, I don't actually check this head, what the node or the data that's inside it, if it's equal to the target value or not. So, and then it's easy to preserve the order because we're just going to increment like this way, one after the other. And also, when we're not, and to remove the value is super easy. You just have to lose reference to the link. So whatever is before it, this would be current. We would just set current.next equal to current.next.next. So it would be, the 2 would now point to 8. We would lose reference to this 3, and Java garbage collection would take care of it. So this one is not too hard. So let's just implement this. Public void remove all, and we're gonna take in the target value that we want to remove. And then if the list is empty, we just want to return. We don't want to do anything to it. So I'll just say return. And then what to do? So here list node current equals to front. And then we're gonna go while current.next, since we're doing a one ahead implementation, while current.next does not equal null, then we would check, okay, if current.next.data is equal to our target, then we want to actually lose reference to this link, and we want to make sure to set the current value's next value to the removed node's next value. So in the case of 4318, current would be at 4, but we would be checking 3. So if we see a 3 here, we'd want to make sure 4's next value points to 18, and we lose the reference to the 3 here. So if current.next.data equals target, then all we're gonna do is say, okay, current.next equals current.next.next. In this way, we lose the reference to this 3, and we actually implicitly increment the current pointer forward, because this 18 will assume the position of 3, and we don't want to skip over this node, so we're not going to like explicitly say current equals current.next. But if the value is not equal to the target, we can just explicitly say current equals current.next and move the pointer one ahead. And like I said, since we're doing this one ahead approach, we actually will never check the head. So I want to show you guys, if we submit this, which cases would fail. Alright, so here we can see all these tests passed where the desired node was after the first node. But here when we wanted to remove one is at the front. It's because we did not do that preliminary check to the front, so we actually never remove it. And in this case, it's the same here, remove 42. Since it's the one ahead approach, and we're always checking, when we're at current, we're checking current.next value. There's no current for the front, so there's nothing before it such that we can check its .next value to check the front. So this is a really simple way to take care of this. So once we break out of the while loop, we'll know that we've removed all the interior nodes that were equal to the target by by losing references to those nodes. So all we have to do is say, okay, if front dot data is equal to the target value, then simply just make the next value. So in this case, if 1 is equal to target, then I just want my front to start at 3 instead of 1, so we lose reference to that one node. So we'll say front equal to front dot next, and that's literally it. This one is pretty easy, not too bad. That should work. Alright, so that works. So, oh, it was muted. I wanted to hear the satisfactory ding ding ding. Alright, so hopefully that makes sense. Let me know if you have any questions. Thanks for watching.